Good evening, guys, and welcome to ML Ticket. And today we are continuing with our sessions, and we are now a part of an ongoing project. We have selected a dataset precisely, to be precise, California housing dataset from 1990, and we are trying to predict the median house value. Okay, so let me just present my screen and let's get started. Okay, so yesterday in the previous session we saw many forms of types of algorithms that we can use, out of which linear regression was the first one that we learned. And I told you, Jay, that it is one of the most easiest algorithm to learn and to perform also. From the point of mathematical from the mathematical point of view, linear regression is very easy to understand. And as promised, today we will be coding this thing. Yesterday, in the previous session, we just went through some of the theoretical parts of the machine learning algorithms, and now we are going to start coding. And I don't think today will be a very long session, because we don't have a much code to write. As I always mention, the code is not the important part. The more important part is that whether you understand the thing or not, whether you understand what I am writing or not. Okay, so code is a volatile thing. Okay, you don't have to be very concerned about the code, because at the end you can copy my code or anyone's code. Okay, but the thing is, you have to put all those things together. Okay, and that putting everything together is your job, and that's why you should understand what you are doing. Okay, that's the first and last thing that I have been repeating from the day one. So let's get started. So let me just go through the some of the variables that we will be using, because it's been a long so we have taken a long time that we have revised those variables. So let me just show you. So housing prepared, this particular variable contains all of our information, but it does not contain our housing median value. And if I am not wrong, that housing median value is in housing underscore, I think, label. Yeah, there you go. Okay, so as I mentioned previous session, that we will be joining these things together, and now this entire housing prepared is the x axis, and imagine that it is a x axis and this is a y axis. Okay, so we have divided our data, we have prepared our data, our data is completely ready, and now it is time for us to start putting this data into the model so that it can be trained. Okay, so how do we do that? So first things first, we are going to create a linear regression model, and let's see what happens after that. Okay, so let's start. And of course, sklearn provides you with a library that helps you create this model. So you just need to create an instance. I am not getting into any kind of complications. I am not going to pass any additional attributes. Okay, right now, because I don't want you to get to complicate this thing. Okay, I'm just going to just create an instance and that's all. So how do we train this model? Okay, so We prepare this model by saying linear reg dot fit. What do we want to fit? We want to fit J. We are going to give you this housing prepared data, and you have to predict. You have to uh, you have to predict these housing labels. Now I am going to explain you this thing once more because sometimes people get confused. So generally that you are going to is this is the x variable, this is the y variable, that's all. And let me just talk about a little bit because some of you may have some problems with this, that how it is doing everything and all. So we are going to input uh, while training we are going to input this data, and also we are going to show them the output. Also I'm going to show the model the output, and it has to learn from that thing. I am going to it's like I am going to give you a question, and I am going to give you the answer to that question, and you just learn. Okay, and this is how I give you about 10 questions. Just imagine that I give you 10 questions and 10 answers. Okay, and now when you have learned all the 10 question, I gave you the 11th question, but I don't give you the answer. Now you have to you have to understand that question. You have to understand that question and make an answer or give an answer. Give an answer as you have learned in the previous 10 answers. You have learned something on the previous 10 answers, so you have to accumulate all the knowledge that you had from the previous 10 answers, and you have to make a new answer. So this is how this is how in the same way our machine learning model can also be trained. That is, we are going to show them the data set, and I'm also going to show them the output, that what data is going to generate what output, and then we are only going to pass the data and it will predict the output. Okay, so let's see if it runs. Oh, it's done. But you people may have asked, say, okay, no, I have seen the it takes so too much time. Mane, people have been training models for days and all. Mane, it just happened in nanoseconds, I guess. Well, how is this possible? Because let me tell you one thing. This is the simplest algorithm that machine learning can have, and the most simplest algorithm and the most fastest, I guess. That's why. So this does not have too much, it does not take up too much computations. Okay, and it's now with our laptops and PC are so powerful. We have so powerful CPU computations that these things can work in nanoseconds. What are you talking about? The thing that you are imagining is about deep learning, and when you start deep learning, you will see things like this. The model has been trained for days and hours and hours. But when you are doing supervised learning or traditional or basic machine learning, you won't be looking at that kind of but still, if you are not careful, you may run out of your RAM, your memory, and it may, at that point, it may throw you an error. Sometimes this kind of problem happens, but I don't think it will happen in my case. But if you are not cautious enough, these things may happen. So now our data is ready, but you may ask, okay, I don't understand. The data is ready, I can understand that, but see, I want to look at some values. I want to get that feeling, right? So let's prepare some data. What is the data that we are going to prepare? Let me just take some dummy data. You remember our housing variable. It has our entire data set. So I'm going to choose the first 5 rows. Okay, what is iLuck? iLuck, we have not used iLuck till now, but it's not very complicated. It just selects the first 5 rows, and it is a NumPy thing. It's a NumPy thing. You can learn about it. I would like you to look on this iLuck thing, but it is nothing too complicated, to be honest. It is just selecting the first 5 columns, first 5 data, and I am going to select the first five labels also. Why I'm selecting this, you may ask. And our labels are in housing labels, and I'm going to select the first five. Now, remember that we are selecting from the training data itself. We are not using the testing data. Now, you may ask why we are not using the testing data. I'll be coming to that after a little while. Just hold on. Okay. So, if you understand by this time, you should have you should have guessed by now that we cannot feed this data. Okay, let me just run this so you can understand. Okay, let me just print some data. Okay. Okay, we have the first five rows of the training data. Okay, you can see, as you can see, it does not contains that median house value. It is in some labels. Other than that, it contains the data. Okay. So by this time you have understood, you should have guessed we cannot feed this particular data inside our model, because our model takes something data like this only, right? But it we cannot feed this particular data. If we feed this particular data, you won't be able to understand, because we have not trained the model on this particular basis. We have done many things, many uh, pre-processing, and then we have uh, given the data to the model. But what do I mean? Then I have to do all this pre-processing that we have done for the last session again. Is that possible? Let me tell you, let me save you some time. It is, you don't have to do that. Remember the pipeline thing that we created. Remember the pipeline thing that we created, and I said, J, this pipeline thing will be our savior as we go. At that point, I was not able to show you an example, but now I can show you an example. Now, if you see, I have this full pipeline. Okay, we have this full pipeline variable which contains the pipeline. But if I just pass the data here, if I pass any data here, it will transform that using everything that is mentioned under the pipeline. Like, it will apply first simple imputer to get rid of the missing values. Then it will apply function transformers. Then it will scale the data. Then it will apply one hot encoding over the categorical values. Then it will combine those columns and make that into the final uh, in NumPy array that we want our data to be in. All this hard work can be done just using this pipeline concept. So we are just going to use the same line. I'm just going to copy this same line, but I am going to put it in a different variable. So let's say some data prepared, and let me just paste it. But we are not going for the entire housing, we are only going for some data, right? um, okay, so let's just run this cell. What happens now? Let me just print it. Yes, now it looks familiar. Now we can say okay, now we have a data that can be fed into the model. Now our model can understand this data. Previously it was not understanding the data. So we have done all the pre-processing that we have learned, we have all wrapped that particular pre-processing thing into this particular full pipeline variable. We can use this anytime. We can just feed the data inside this pipeline, and it will transform the data, which can be fed into the machine learning, either for learning, or either for training set, or for testing, or for prediction. Okay, so that's why I did that pipeline thing. It is very, very essential for you to do the pipeline thing. You should more. I would again prefer you to read more on this pipeline and feature union, because it's very useful. Okay, so let's just continue. But still, I've made no predictions. How do we make predictions? So let me just predict some things. predictions. Okay, so we have selected the first five rows. We are going to predict first five rows. And the first five median house values. So how we are going to do it? We are going to choose the linear reg. We are going to use a function which is predict. I am pretty sure that dot predict is self-explanatory, and I don't need to explain that what predict function does. It predicts data, and now we have to pass our some data. But remember, previously we were training the data. That's why we passed two parameters, right? We passed the question along with the answer. But now we are asking, right? Our model is taking the test. Okay, so we are only going to ask question the data, question the model, but we want to be providing the answer. The model is to going to provide some answer, or the model, we can also say the model is going to predict some answer. But we have our own answers, right? We have our answers ready. Which is Where is our answers? Our answers are in labels, right? Like in some labels. Some labels has our have our particular exact median value that is present in the data set. So we can make a comparison and understand that what is going on, what is the prediction that we are getting. Is our prediction good or bad? Let's see. Oh, we have a error. Okay, matmal input operand 1 has mismatched score dimension is 0 with gang function signature. Hmm. What's wrong? Hmm. I think we have a problem here. Wait. Let me just get to the bottom of it. Let me just delete the code that I've written. Okay, so I am going to try to solve this. By this time, I'm going to just discuss some of those things that we have till discussed, so that you can understand. Wait, just okay. So just let me just give me a moment. So just let me just tell you one again the entire thing that why we are using this pipeline concept. This pipeline concept, as I mentioned, this helps the data for to transform the data in a linear fashion. Okay, if you have not used pipeline by this time, if we have not made those efforts to create that node, create that pipeline thing, so we need to do this when we are trying to get some this kind of we are trying to extract some of the 5 rows from our training data and trying to get the predictions. We have to do those all this pre-processing again, from the very top we have to do those again. But we don't want to do those again, right? That's not wise enough to do also, because at this point if you do those things, it's nearly a waste of time. Okay, so that's why we have used this particular technique to do stuff. Okay, so okay, I think I have some problem with this particular AI. I need to resolve that. But till date, you can look at my spare file. I have always made a spare file for this thing. So just look at it. So I did the same thing. I have pre-coded these things because I have run into this particular issue once also, but I cannot figure out why it is not working, because I am writing the same code. Okay, these things can happen. Okay, you cannot get over these things. Sometimes code doesn't work, but the concept remains. But as you can see, that here we have written the same code, and we have made some predictions. So this is the first prediction that it got us, and this is the second prediction, and all. And as we go, we make many other predictions. But as you can see, that these predictions are sometimes not very great. Okay, so sometimes these do not stand out. Okay, you cannot understand this just by looking at this particular 5 predictions and make out whether this model is good or bad, because to be honest, you are just touching the tip of that iceberg. So you need to have some metric to understand this particular thing. So what is the thing that we can use? So the another metric that we can always use is RMSE. I have mentioned this particular thing yesterday about RMSE, right? We have I have told you to just go through this RMSE once more, because it makes your life a little bit easier. So we are going to look at the RMSE score, and we are going to understand what score we are getting and what observations that we can make. So let's get to the code. Hope that it won't create an error this time. You never know. Of course, we have a library named mean squared error, and and but it is just mean squared error, but we need root mean squared error, so we have to apply another square root over this particular thing, so that we can work with it. So let's see what happens. So I'm going to make the prediction here on the entire data set. I think there's some kind of a problem that is going on. Let me just run this cell. Okay, it is running here perfectly fine, but it is not predicting values here. I do not understand this thing. Sometimes you may face this kind of problems. There's nothing to be worried about. You just need to go through it. Actually, it is saying that I need 16 columns. The housing prepared when this prediction input needs 16 columns, but it has only 14 columns. I think that's why I'm doing something wrong here. Cannot generate the 16 columns. It should generate 16 columns. Let's say what happens. Whatever, but it is works here. It's the exact same code. I think, of course, if you find the mistake that I am making, please let me know in the comments so that I can rectify it. So I'm going to use this library, that means square error. Don't worry, I'm going to apply the square root over this. So it takes two parameters. Minimum it takes two parameters. One is the final predictions, that is housing labels, and the predicted values. Housing predictions, yep. And for Rmse, it is just MSE. Rmse, we need to apply a square root. So we need to apply, I'm going to use the numpy square root function, np.square root, and I'm going to pass this particular variable. And that's all, I guess. End of this particular data. If you just look at this graph, look at those graphs again, you will understand. So the typical prediction of 68 28 is kind of is not very satisfactory. Like it is, and it is saying the typical value, that the typical house value is between this and this. Okay, and now it is predicting something 68,000 only, so it is way less, and to be honest, not satisfying. So this, what you are looking at right now, is an example of underfitting. Let me just get back to the definition one more time. It occurs when the model is too simple to learn and the underlying structure of the data. You can imagine that as sarcasm. Reality is just more complex than the model, so the predictions are bound to be incorrect. So what are you looking at right now is an underfit model. Why it is underfit model? Because it is not making the correct enough predictions, right? That's why it is that is why it is underfitting the data, or it is underfit model. Okay, it is very important for you to understand this concept between overfit and underfit. I'm going to show you an example where you will see an overfit data, but till now this is an underfit data. This means what it actually means is that the features do not provide enough information to make a good prediction, or the model is not too powerful enough to extract that information. So we can now the thing that comes to our mind, okay, so we made our first model. It is a linear regression model, and it is a underfit. Oh my god, mane, at least first things could have been a little bit better. First thing, and it comes to an error. So what we can do, what we can understand, the first thing that we have to understand, one thing, that this linear regression algorithm, as I was saying from the previous session only, is the most simplest machine learning algorithm. Okay, it cannot extract those hardcore features from inside the algorithm. So that's from the data set, sorry. So that's why it is saying that the model is too simple. Model is so simple that it cannot understand the underlying features. So this can be solved in two ways. Okay, the first way is to uh, make more columns so that the model understands. You can make more columns so that the data is more correlated so that you can understand it better. Okay, and another process is to use a powerful model. Okay, how to use a powerful model? That is the same thing that I am saying, to use a good algo for this. Okay, so we made our first prediction using linear regression, and we can understand that okay, there is something wrong with this particular algorithm, and it does not make a good prediction. So we need to move on. We don't sit back and think they were cry over the fact that why we are getting a bad number. So I am going to use another model that we have talked about, that is decision tree. Since it's a regressor problem, we are importing the decision tree regressor. Okay. Okay, it requires a random state, and I'm going to use the random state of 42. Why I'm using 42? It has a mathematical significance. I would like you to go through that. It's quite interesting. Not related to machine learning and something like that, but it's an interesting thing to know. Similarly, housing predict prepared, first parameter. Yeah, and next parameter is housing labels. Same way. This particular arrangement is similar for every model, so you don't need to worry. So fingers crossed. Okay, we have an importer. I think I have made a typo. Let's see. Oh, we have done it. So it's the model. We have our model. Now let's try the same RMSE thing. Okay. So let me just copy this thing. Okay, why should I write this thing again? I hope that it is the same thing. Let me just go through it once. Housing prediction, not linear reg. I am going to use tree reg. Predict RMSE. Housing labels is okay. Housing predictions is okay. Square dot. I think I need to change this variable. Tree. Tree and tree, and of course print tree. Fingers crossed. Okay, 0. Oh, it means our model is completely fine. It is saying right now that okay, my model is so good that it made absolutely no error. Now tell me, is that possible? Is that even possible for a model to not make a single error? This is not likely to happen. So this type, when you get this type of result where the RMSE score is 0, so that the best fit, that it predicted exactly the same thing that we wanted. If this is the case, then we have to assume that our data is overfit data. So this data is an overfit data. Now basically you don't want your training testing set to look on the your sorry you don't want your model to see the testing set right now, because if you feel okay, it is working so good on the training data, right? So let's try it on the testing data. You will see it will horribly fail in that particular sector. I'm not going to show you right now that thing. I'll be showing you it in the next session, I guess. But if you just try to do that prediction, you will see it's a horrible thing that you will be getting. It won't make the right prediction at all, but in your data set it is making the 100% so good prediction. So that's why we have seen we have seen two types. We have seen this underfit data as well as overfit data. So it is saying the general idea is now like this: the linear regression model is coming up with something underfit, and the decision tree is coming up with something which is overfit. Now how do I choose? Both are equally bad right now. So how do I choose? But I would say okay, we made a prediction, we made a accuracy score using RMSE score. That's completely fine. That's okay, that's good. But to be honest, this is not the efficient way to do this thing. Okay, we should not do this thing like this. Okay, the more efficient way is to use cross validation. Now what is cross validation? I'll be talking about cross validation in the next session. For the entire session I'll be talking in a great detail about cross validation, so don't you worry. So this is the first look on your decision this is first look on your model training. You have trained two models. In one you have used linear regression, and another you have used decision tree regressor. Okay, so that's how you that's how you have first at least if you have not done machine learning, congratulations, you have your first model, and it can predict values, and to some extent it is correct, but it is not perfect. But we need to understand how it is not perfect, where it is lacking. We have to understand these things. We have to take out all the mistakes that is making and make sure that it does not make that mistakes again. So uh, if you remember that yesterday we talked about random forest. We talked about random forest regressor. You may ask, okay, why I am not just applying random forest regressor right now. I would say I'm saving that for tomorrow or for the next session, so that we have some another model to look at tomorrow. So this is where I would stop today, because otherwise it will be going over your head right now. And sorry for that, for this error. I have to look into it. What is the problem that is going on here? But to be honest, this is not something very, not something very, to be very, uh, no, don't need to care much about this, because I just was creating a sample data out of it. It is not something very important right now. The important part is this: if this thing did not work, then I would have freaked out a little bit. So uh, fingers crossed it worked right now. So I will be looking into it, looking into the problem that was caused there. But of course, I would like you to go through this particular thing. Some of you may not have understood this, how this thing, this predict function and fit and transform function are working. But to understand it completely, I would say you just need to do this thing on your own. One You do this thing for like one or two times, you will understand what is going on in here. What are the things that we are considering while making a model. How At what point the model is overfitting, or what point the model is underfitting. Now I would say this overfitting and underfitting is a bit confusing for some people at the beginning. Even when I started, I was very struggling with this concept of overfitting. To be honest, when you understand this tip. I can just explain that thing in one line. Overfitting is overgeneralization, and underfitting is too simplification of that, extra simplification of that particular thing. Okay, so I can just explain you this thing because it is still clear in my head. Okay, but until the point you actually read about this overfitting and underfitting on your own, you won't be getting the vibe. And most of it, you may ask, how are you understanding this particular data is underfitting, and this data is overfitting. How do you understand this thing? Well, now, if you want to understand these things, you have to practice. So you have to go through a lot of data sets. You have to see a lot of videos, I guess, other videos, the YouTube videos. You have to look at other projects, other people's code, and dhire dhire, slowly you will get to know that which data is underfitting, which data is overfitting. Sometimes it's confusing. I would say, as a beginner, it is a little bit of a problem for you to understand this thing. But as you move forward, as you understand things better, you will start having the feeling. You will understand what is the difference. I can just tell you the difference. I can tell you the difference, and you will also understand the difference. But unless and until you start doing this thing on your own, you won't be able to get the full content of it. Okay, at this point I can actually you can teach you I can teach you about preprocessing and other methods and all. But this machine learning algorithms part is a very complicated, it may get sometimes very complicated. Okay, so it is better for I am going to explain you everything that I could. But as a beginner, you won't be able to understand everything that I am going to say. So I am going to make it as simple as possible. Till now I have made it as simple as possible, but if you have any kind of questions, please let me know. I'll be happy to answer them. And of course, if you have a question later while practicing, just drop that question over on the WhatsApp group, and I'll be taking care of it as soon as possible. And you just need to go through these algorithms, read about these algorithms a little bit. I know if people don't want to read about algorithms, that is a little boring stuff. But this is the thing that you should do. Just get familiarized with these things. Once you get the heck of it, you will be understanding it in any way. Okay, so this is where I end today, and hope that you are enjoying, and we will see you tomorrow. We are almost at the very end of our project. We have almost completed our project. We are just need to make some accuracy scores. We have to make some we are only going to see on some of the metrics that how can you look at the accuracy of that model. And that's how we are going. We are at the very end of our model, and I'm going to at the end I will be showing you a way to I will be showing you a way to fine tune your model. This is a little bit fine tuning your model is a little bit intermediate. I won't say intermediate. I would say intermediate stuff, but I'll still show you the thing that about this fine tuning. If you don't understand this fine tuning completely, it's completely fine. It's no, that's not a problem. But as I have promised that I'll show you everything under the roof, under the beginner's roof of machine learning, I'm going to show you. So stay tuned and just go through the algorithms. You will start to understand them better. Okay, so you people can sign off.